So hello everyone, welcome to the webcast on automation of AnyBody models. So I'm Arne Kies, I'm the webcast host today. So in a minute we'll introduce Morten Lund, who is our presenter today. And before we do that, I'll just do a very short housekeeping. It's a smart feature of this format that you can actually type in your questions to the presenter as you go. So during the presentation, you can open up the control panel and type in your questions. During the presentation, our colleague Moonki Jung will be monitoring the questions, and he might type in an answer to your question, or he might leave it to Morten to reply to your question after Morten has finished his presentation. With this, let's get on to the first slide. And this is actually not about automation. It's just to say that this presentation today is not really very much about the AnyBody modeling system, or it's not very much about the models that come with the modeling system. It's not about the consulting and training support and partners of AnyBody technology. If you have any questions related to those topics, shoot us an email, and then we'll try to reply as good as we can. With this, we'll get going with Morten Lund, who will present about automation of AnyBody.
Thank you very much, Arne, for the presentation. My name is Morten. I'm an engineer here at AnyBody Technology, and today I'm going to present to you how you can automate the AnyBody modeling system, or how you can use the AnyBody modeling system from Python. The first thing we have to answer is, why do you want to automate your simulations? And one of the three good reasons is stated here. Well, the first is to reproduce your workflow. And that's in general very important when you work in programs who have graphical user interfaces, because there are so many ways that you can do your workflow by clicking around in the model. Another good reason is to do batch processing of many models. This was also the topic of last week's webcast, so if you haven't seen that, I really encourage you to do so. In that webcast, John Rasmussen and Kasper P. Rasmussen from Aalborg University, they presented a study where they ran 16,000 simulations. And each model contained a different person with different anthropometrics. And all the anthropometrics were taken from a population database. They used this setup that we're going to show today exactly to run these 16,000 simulations. Their model was relatively fast and easy to run, so they were able to run all of these simulations in a night. A third option is to explore the effect of different inputs. And these are typically parameter studies or sensitivity studies. It seems to be a trend at the moment that a lot of sensitivity studies and musculoskeletal modeling is coming out. One example of this is a paper as we published last year. It's not per se about a sensitivity study, but it presents 3 different modeling approaches. And a part of that is that we investigate what the sensitivity of the 3 models is to some certain inputs. And in this case, we do so with a Monte Carlo study. So we run the models 1,000 times with random offsets to these markers, and we observe the output. What you see here in the graph is the predicted knee force compared with the experimental values for the 3 models, and the shaded areas, they represent the uncertainty in the values or in the model outputs by perturbing the inputs. But before I continue, I just want to talk about what kind of model we're going to use for all the examples in this tutorial. We're not going to use a real model here because we want all the examples to really run fast. So we're using a very simple model of the knee joint with only one muscle, and it only has one main file, and it runs in less than a second. And before we start to talk about the Python stuff, I just want to introduce the AnyBodyConsole application for the people of you who haven't used it before. If you have the AnyBody modeling system installed, if you open up the installation directory, you will see that you have the AnyBody .exe file here. This is the main AnyBody modeling system, the graphical user with a graphical user interface. But there's also an exe file called AnyBodyConsole.exe. And that's the console application. And it's basically the AnyBody modeling system, but without the graphical user interface. So let's try to open it up. I'll just click here. So when you open it up, we sort of get a command prompt, as you see here. And what can we use this for? Well, we can type in macro commands here. And a macro command could, for example, be a load command. You can say load me.any. And that loaded our small example model. And we can continue typing macro commands here. We can type a macro command that selects an operation. We could type a macro command to run a simulation or saves data, etc. I'll just type exit to exit this. So we'll close it down again. So the macro commands, here's just the example I had, the load command. It loads a file name and it takes also some arguments. You can set define statements in the model or different pass statements as well. And there are many macro commands. Most of them correspond to what you can do in the graphical user interface. So in the graphical user interface, you can click load model, and this has the corresponding macro command load. You can also click run, and there is a corresponding macro command run that does the same. You can select operations in the operation tree, or you can right-click elements here in the model tree, and then you would have some options. And these options are basically what we call class operations, and those you can access also with a macro command. But there's not much fun in just typing in the macro commands. So what you really want to do is you want to put all your macro commands in a file if you want to use or automate your system in this way. So here I put a number of macro commands into a file, and then we just want to pipe that file into the AnyBodyConsole application, and it will run each of them. I'll just show a simple example of how this is done. Here we open up a command prompt again, and this we just write AnyBodyCon.exe. We give it an m parameter for a macro file, and then we specify our macro text file. If I execute this, it quickly loads the model, selects the operation. In this case, it was inverse dynamics. It runs it, and then it exits. It saves some data, and then it exits. So this kind of illustrates what you can do if you just want to do, or what you can automate if you just want to do things manually. So this brings us to all the live examples of this webcast here. We're going to run AnyBody from Python. And if some of you don't know what Python is, it's a modern object-oriented language, and it's a programming language, and it's quick and easy to learn, and it has a lot of open source libraries that you can use. And for people who have no idea what I'm talking about here, you should think of it as sort of an open source version of MATLAB, where all the toolboxes are provided by lots of people from around the world. And from here, I'm gonna switch from this presentation over to a live presentation to do some coding here. So first of all, to use AnyBody from Python, we're going to use a small library that's going to help us do a lot of these things. And the library is called AnyPyTools. And it's a small library that handles all the interaction with the console application so that we don't have to type in these macro commands manually into a file and launch them. It will also allow us to create macros programmatically, and we'll see in a minute why that is smart. And it will allow us to run simulations in parallel. So how do we get started? Well, first of all, of course, you will need a Python installation, and you would need to have the AnyPyTools library installed. And the easy way to do that is to install a Python distribution where you get both the Python programming language and all these extra packages that are needed. And an excellent choice is the one here from the company called Continuum.io. It has all the important scientific Python package. It's free also for commercial use and redistribution. And most importantly, it comes with a built-in package manager. So once you have it installed, it's really easy to install AnyPyTools. All it takes is this line of code from the command prompt, and you will have the library you need to work with AnyBody. So let's get started from here. We'll run some real code. In reality, these small code snippets would usually be put into small files called Python files, and then will be run with Python. But in this case, to illustrate it, I'm going to run all these code snippets directly here in the browser. So the first thing we want to do is import. We want to import our library, and the library, it has a small class called AnyPyProcess. So the first line is from AnyPyTools, import AnyPyProcess. And now we can use this small class, and we will instantiate it and put it into this variable that you see here. So I'm going to run this first line of code. And the next thing we want to do is want to create a list of macros. In this case, we have created a list totally manually here. The list contains the first string that says load me.any. It has a class operation that sets a value, and it selects the kinematic operation, it runs it, and it exits. And once we have created this list of macros, we're going to put it into our small AnyPyProcess object. It has a method called start macro, and it takes as input our macro list. And if we run this, behind the scenes, what will happen now is AnyPyProcess will put all these macro commands into a file, pipe them to the AnyBodyConsole application, and it will then get all the data back or monitor what happens, and then it will issue whether the simulation succeeded or not. In this case, it did, and it took 0.6 seconds. So let's move on from here. Besides running a single macro, we can also run multiple macros. And in this case, we have constructed, again, a macro list. But here we have it as a set of two sets of macros. We have first one that runs kinematics, and then we have a small macro here that runs inverse dynamics. And again, we can put this macro list into our start macro method. And running it, you see it ran two operations, or started the AnyBodyConsole application twice. So, but what you couldn't see here on the previous slide was that these two operations were actually run in parallel. And to see why that matters, we can try to create a lot of macros. Here we will again create a single macro, but this times 40 here will replicate that macro 40 times. So let's try to do that. I can show you here that we actually have 40 macros if we scroll down. So now we have 40 identical macros though, but if we just run the AnyPyProcess with one process at a time, it has this kind of argument that you can set, then it will take a while to run these 40 models. Every time one is finished, it will start a new one. But we don't have to do that. We can also do the same thing with parallelization. So we can set the number of processes to be 10, and this means that it will run 10 concurrent processes at a time. In this case here, we can see, well, you can see here it took 23 seconds to run these 40 macros, and now we'll run 10 at a time and see how long that takes. And here it constantly has 10 simulations running at a time, and it only took 4.7 seconds. So there is a speed up to gain. It's not 10 times as fast here, and the reason for this is that my computer doesn't have 10 cores. So choosing a number that corresponds to the number of cores you have on your computer is probably the best thing to do. And there is also, of course, also some overhead of starting and stopping these simulations, especially when the model is as little as it is here. So the next thing we're going to talk about is how to get data back from AnyBody. The usual approach in the AnyBody modeling system is in your model to include a class called AnyOutputFile. That class will collect a number of variables and write those to a comma-separated file. Another approach is to save all your data. You can do that from the model tree. You can save it to a file format called APF5, and it's a nice, widely used file format within Science. So you can load these kind of data in MATLAB or any other system that can work with these kind of data. Sorry, but it can be difficult to work with data in this way. For example, if you run many simulations, you will have the difficulty of concatenating all your data across the simulations. And it can also be impractical to use these kind of methods if you only need a few variables, or if you are exploring and you wanna change the variables you want out. So there must be a better way, and it turns out that when you use this library here, if you use AnyBody from Python, there is a better way. And the way it works here is that the console application, it has a class operation that we can use. And that class operation is called dump. So if you run that class operation on an AnyScript variable, the console application will write that AnyScript variable out inside the console. That might not seem very useful, but the Python library will grab any output from the console application and make it available in Python. And we will see that in a second here. So here we created two macros again, but we have included in the macros a class operation to dump the maximum muscle activity. So these two macros will run, and it will dump the maximum muscle activity. And let's try to run these things. Execute our macros, and now we can look at what came out of this. So we have assigned the output of the start macro method to the results variable here. And let's take a look. So this shows us what we got out. So on the top level, we can see here we have square brackets, and in Python terminology, this means that this is a list. And it's a list of something that starts with curly brackets, and curly brackets are hash tables in Python. So these are small dictionaries, and you can see the keys in these dictionaries are actually our AnyScript variable. And the actual data here is some sort of array of numbers. Let's explore that a little bit further, because we can actually plot it as well. And the first thing I'm running here is I'm importing some package to do plotting. And then I'm selecting from the results variable, I'm selecting the result of the first macro. So in Python, everything is indexed from 0. So 0 is the first element in the results list. And then I'm selecting the AnyScript variable called maximum muscle activity. And I'm putting this into a new variable, and I'm just plotting that variable. So let's take a look at how that looks. So here we see the maximum muscle activity from our small toy model. And the output that we get from running these models, they behave very much like default Python data types, like a list or a dictionary. But they do also have some extra convenience functions, and I'm going to illustrate this. If I just remove this here and run, you see I can access the actual data. It's a long array. If I just write shape here again, I can see that the shape of this data is 100. It's a vector which is 100 long. Now, what happens if I remove this first index where I go into the list? So this wouldn't normally, if this were a default Python types, this wouldn't be possible. But what happens here is that it concatenates automatically the data. So instead of just accessing this vector of 100, we now get a matrix, which is 2 by 100. This can be kind of nice in a way, especially if you have large data sets. But you can do more than this. You can also, you don't even have to write the full variable name here. As long as the variable name is uniquely defined, it will also find our data. So in this case, since we only have one variable, we can even cut it down much, much further, and it will still find our data. And it also handles errors, because if you run these kind of models, you will often get errors. And sometimes you get errors because you type things wrong, and we will use that as an example here on how to catch these errors. So here is a macro where we misspelled an operation. Instead of writing main mystudy kinematics with an S, we have forgot the S. So running this macro wouldn't work. We would get an error, and I will show that now. So here we start the macro, and we'll see what happens. So it reports that it ran one macro, but there was one error, and it says that it tells us that this one model ran in 0.46 seconds or something like this, and it also gives us here a small link to a log file. And for security reasons, I can't just click it here in the browser, but I can say copy link, and I can paste it into a new tab here. And let's open it. And now we open the log file. We could also go down and found it directly in the folder. And here in the log file, you can see in the top which macro was run, and we can see the output from the console application. So if we scan down over this, we can see down here it says operation, my study, kinematic, and anybody reported that this was an error, it can't find that object. So this can be nice to investigate what happens if some of your models fail. And we also put the output of running the start macro operation into the result variable. And if we look at that variable like here, we can also see we can get the same error here. So having that error available in this result variable is also nice in the sense, let's imagine you have run thousands of simulations and a few of them failed. Maybe you want to rerun only those who failed, then this becomes quite handy, or maybe you just want to exclude those that failed. Then it also becomes quite handy that you actually can see which models that ran, which that failed. So the next thing we're going to talk about is how to create these macros programmatically. So why would we want to do this? Until now, you've only seen that we've written those macros manually. But individual macros, they can be really long and complex. And parameter and sensitivity studies, they may require thousands of different macros. An example of this is actually from the study that I started with here in the presentation. Let's just run this and we can see an example here. This is a sensitivity study where we in the beginning first load a kinematics model with a lot of extra arguments to set different kind of path statements and define statements. And then there is a lot of class operations here that set some values for marker positions. And these values here will be different for every macro because it's a sensitivity study. And then down here it loads the model again. Here this time it's inverse dynamics, again setting a lot of different path statements and define statements. And it runs the operation, and in the end here we save a lot of the output that we are interested in. So this is a long macro from one of our studies. And writing something like that manually is kind of hard, of course. So the AnyPyTools library, it has a sub-package called macro commands, and from that we can import a lot of our macro commands. And some of those, for example, load, operation run, dump, and set value, you might also know. If we add a comma here and press tab, we can see what others are available. So there's also ones for saving, design, loading values, many of the things that you can do in AnyBody. But for now, we will only use these here. So the load command here, if we just specify what thing we want to load, it will just print the load command out. And for the set value, we want to specify what value we want to set, as well as the value that we want, and then we get the class operation or the macro command for doing that. And of course, this can be combined into a macro list as well. Here we are generating our macro using those commands here, and if we look at it, we can see we actually get the list of macro commands that we want. And we can also, of course, start that. But we also want to generate many macros, and to do this we need a little helper class. And the helper class here is called AnyMacro, and we have imported that as well. And we wrap our list of macros with that helper class. And that helper class, it adds some small extra functionality. And one of those things that it adds is that you can set how many macros you want. In this case, we said now we want 2 macros. And if we run the code, we see we get 2. In this case, they're identical because we just set a single value up here. But if this single value wasn't a single value, if it was a list of values, then these things starts to make sense. So in the next box here, you see we have a parameter list, and it is a list of 5 values. And we put this parameter list into our set value command. And we generate a macro list. And now again, we generate 5 macros. And in this case, we can see that our 5 values here from our list have been distributed across our 5 macros. And this is, for example, what you can use for parameter studies. So in the next thing I will try to do is combine all of these things in a parameter study. And we're still going to use our small toy model, and we will vary the patella tendon length in this toy model from 2 to 8 centimeters. So the first thing we want to do is create a list of different values that we want to use. We've created that here. So then we create our macro. We first load our small model need.any. Then we run the set value operation on the patella length. And then we have an operation run to say that we want to select inverse dynamics. And then we dump 3 values out here. The time value, the length of the patella, that this was also the input, and then we dump the maximum muscle activity. In this case, we generate 7 macros, and we can take a look at those 7 macros here. So let's try to run those. You can see what happens. It goes fairly fast. So now we have run our 7 macros, and we have all the output here in this output variable. And now we can start to plot it. So to plot it, I will again import the functions we need to do this plotting. This was the first line here. And next we will loop over the data and create the plot. And for those of you who are maybe not familiar with the Python syntax, this is in Python language a for loop. And the data variable, for each time we pass through the for loop, the data variable will attain the value of the elements in our output list. So in the first case, data will be the output of our first macro. So in the first loop here, we get the maximum muscle activity, we get the time, and we get the patella tendon length, and then we plot the stuff. And the last thing we do after the for loop is we add a title, we add a label, and we add a legend to the plot. Let's try to generate this, and then we get these nice plots here of our model and the parameter study. So this was just a quick primer on parameter studies. The next thing we're going to talk about is batch processing. How do we do batch processing? And the approach, it very much depends on how the AnyBody model is structured. So if your model is structured has a setup with a single main file, then the usual approach is to load the model, modify some parameters. Maybe you modify what kind of input files you want, specify which C3D file or what input data you want to have. Then you run the model and you save the result. And in that setup, every macro is really different. And it's not that different from the parameter study that we just showed. Maybe the parameters, instead of being values, then they are string values pointing to a new patient or a new subject. Another setup, which a lot of our users also use, is a setup where instead of having just one main file, you have multiple main files. And these main files are really small, and all they do, each of the main files, is include some sort of shared model. I'm going to show you this setup in a minute. But in this case, each main file defines its own parameters, and in that case, all parameters, all macros will be the same, and the main files will be located in different folders. Just to show you what that means, take a look at this case here. In this case, we have a shared model. It's the ARM2D demo from the tutorials that comes with the AnyBody modeling system. And in each of the subfolders called model 1 to 9, we have a model. And if we look at here at one of those subfolders, we have a main file in there. And that main file, all it does in this case is it includes our ARM2D model, and then it sets some variables which are specific to this particular file. So this kind of setup can be expanded, and it's particularly useful for mocap models, I would say. If you have thousands of different trials, it makes it easy to click around, open a specific trial, load it up in the AnyBody modeling system, see what happens. But if you have a setup like this, you also really want to batch process it. And this is what I'm going to show how to do now. So again, here we just import the load command and the operation run. So we create a small macro. All this macro does is that it loads a file called main.any, and then it runs inverse dynamics. So in this case, the actual macro will be the same for all the different models, but we run our macro on different subfolders. And to do this, we pipe in our our macro here into the start macro method, and we specify the search subdirectories attribute that we can set here, our argument. And in this case, this is a regular expression search string. So we say that we want to match all the subdirectories where there are files that match something with model 1 to 9 and then a main.any. So this will find all the subdirectories where we have a main file in. So let's try to do this. First, we generate our macro here, and then we run our macro. Now keep in mind there is only one macro here, but since we have a search directory, it automatically finds all the subdirectories that matches our search string, and then it executes that macro on all those 9 sub-models. So this makes it possible to do batch processing on models that has this kind of setup. So what other possibilities do we have? Now we come to the end here. So one of the other possibilities is you can do Monte Carlo simulations with this kind of things. Here we have an output example also from our small toy model here, where some of the parameters in the model has been randomly varied using sort of Monte Carlo approach. But you can also do the same with Latin hypercube sampling, or you can use the whole Python library as an interface using external optimizers. So the Python library will sort of be the one that talks to AnyBody and starts up AnyBody, and you can then wrap the whole thing using external optimizers. And all of these 3 things might be topics for a webcast we will hold in the fall. But for now, if you want to know more, at least about the Monte Carlo simulations and the Latin hypercube sampling, we also have a tutorial that you can read. And this tutorial you can find using this link, and we will also distribute links afterwards in the material from this talk. So I hope this gave you an idea of what you can do using this Python tool when working with AnyBody, and how you can automate your model simulations.